So welcome once again. Now today our main aim is to work with the objective number 2. The objective is design a LX code to identify and print the valid identifier of C++ for the given input pattern. So we have uploaded the previous video. In previous video, we just given the overview of the regular expressions. So putting this thing into the consideration, I'm assuming that you all are aware with regular expressions, which we have also seen in the last semester under the theory of computation. So if you have not clear the concept of regular expression, please go through the previous video in which we cover the all aspects and the application as well as the implementation of the regular expressions for compiler point of view. Now, let's see what is an identifier. An identifier in C or C++, that is identify itself. Let's suppose if there is a variable x, then in general way, it is a variable. But in programming language, until and unless its scope is not defined, it will not going to allocate or get the memory from the computer. Why? Because if we not define the data type, all right, of this particular variable, then it will not going to allocate the memory. And if it is not going to allocate the memory, it will not going to participate in the particular program. All right. So if I talk about the identifier, so let's see some examples. 1 2 3 a 1 2 3 1 2 3 a @abc 1 2 3 abc ab 1 2 3. So these are some examples. Okay, now is it an identifier? Absolutely no. Let's choose a pencil. Is it a valid identifier? No, it is not a valid identifier. Is it an identifier? Yes, it is an identifier. Why? Because it is like this: A, 1, 2, and 3. What does it mean? It means the starting letter is an alphabet. And at the end, it may possible any combination of an alphabet as well as a number. All right. Now, next is, if I talk about 1 2 3 a, so is it an identifier? Absolutely no, because the pattern is starting with a number. So an identifier is not supposed to start with a number. Is it an identifier? Yes, it is a valid identifier. Why? Because it is going to be start with an alphabet, then number, and then alphabet. So if I talk about the 1 2 3 ABC 1 2 3, is it an identifier? Absolutely no. So what is the structure of an identifier? The structure of an identifier is it should be start with an alphabet. It should be start with an alphabet, and it should have any combination of an alphabet plus the digit, any combination. All right. Now, an alphabet must belongs to capital small a to small z and capital A to capital Z or special characters. Special characters means at the rate, hash, all right, like these. All right, now what is D? Digit belongs 0 to 9. Any number which belong to 0 to 9. So what is the valid identifier? A valid identifier, if I talk about the valid identifier, then what is the combination of valid identifier? A to Z. Capital A to Z. It should be in starting like this one. Like this one. Okay. It should be like alphabet. And a combination of an alphabet as well as the digit. Combination of alphabet and digit. So this should be the same here, and 0 to 9, the whole estate. All right. Now this is the rule section. This is going to construct under the rule section, and the remaining all things is supposed to be same. All right. So if I talk about the automata, finite automata, sorry, how the finite automata will look like? The finite automata will look like this. This is the initial state. All right. Initial state is A, let's suppose. Now it should be A to Z. It should be small a to Z. Okay. Now, any combination of A to Z, A to Z, and any combination of 0 to 9. So this is the final state. So this is the DFA for the regular expression. All right, this is general DFA and this is the general regular expression. All right. Now, how are we going to implement this particular code? So the procedure is same, quite same. So the first is rule section. All right. So first is basically the declaration section. Declaration section. All right. Declaration section. Inside the declaration section, what we're going to do is we're going to declare the header file. All right. If we are going to count the number of variables, identifier, then we need to take an integer number, integer counter, and initially it is supposed to be initialized with 0, right? If you don't want to count, then leave it as blank. Okay, you just need to provide the header file. Now inside the rule section, what we need to do is, in the rule section, the first rule is like this. It is A to Z, capital A to capital Z. All right. You can write here like this one, this one, this one, this one. It's up to you. If you want to include this, then you are supposed to write the same. Otherwise, you are not supposed to write, right? So this is what? This is the combination of all alphabets. Now, again, I don't know what is happening. Its value is changed. Now this is complete, and this box will be the same, right? I'll paste over here, and I'll write and then I'll write here 0 to 9 and it's asterisk. All right, so this is the whole regular expression for what? For valid identifier. Now, if any number is found, then we can print. What we need to print? We need to print printf number. Otherwise, what we need to print is, we need to print valid identifier. Okay, and the third rule is dot. Anything except this pattern or this pattern, it should go under wrong input. Everything will be considered into this dot, right? So this is the end of the rule section. Now, again is subroutine section. So subroutine section is the same as in previous videos. Okay. So now this is the document. So let's compile, let's begin with the practical. So first is the rule section. So inside the rule section, what we need to do is we need to declare the header file, include stdio.h. Okay. Okay. Now, what is the rule section? Here is the rule section. So how can we write rule section? We can write rule section like this. So inside the rule section, we'll simple write A to Z and capital A to capital Z. Then we will copy this once again and write here, and we'll write asterisk over here. All right. Now we'll 0 to 9. So this is the rule. This is the sign for valid identifier. Okay, valid identifier. Okay. If I write here anything else, okay, then what we need to write here? Right, not an identifier. Okay, so this rule section is over. All right, this rule section is over. Now this rule section is over, and subroutine section is, the subroutine section is same. Okay, like in previously, I'll copy this and I'll paste here. Now what I supposed to do is, we supposed to do it save. Okay, I'll save here and compiler design. I'll write here valid identifier, save, replace. So it is got replaced. Okay, so this is the program. If I write it, if I open it, then it will look like this. Okay, probably here is an error. Yes, this is an error. If I modify it, then I can modify it like this. Similarly, \n. And if you want to one more time modify it, then we'll write here like this, and like this. So this is the rule. Okay, so now this program is saved. Now it's time to execute it. So lex valid id.l. Let's see, it is got compiled. Now cc, what we need to write here is, we need to F2, then we need to copy it, then paste it and enter. Okay, now its output file is generated. How can it will save? It can be seen. So if I go to the properties, then it is reflecting the time 3:17 p.m. 5 Feb, which means it is generated right now. So what we can write here is a dot out. So if I write 1, 2, 3, not an identifier, not an identifier, not an, why it is giving not an identifier every time? Because there are 3 numbers, 1, 2, 3. So each and every number is supposed to be under not an identifier. Now how this problem will get resolved? You have to do specific the result, the rules. As I said in our previous lectures, that if you want to get the exact output, then what you do is, you need to do the specific rule. You need to write the specific rules. These are general rules. If I see, these are very general rule. This is very general rule, right? And this is again very general rule. So if I make more specific this rule, then answer should be different. So Control D,